Postgres version 14 beta 1 has just been released with a lot of exciting new features. And I usually do these kind of videos where whenever a new Postgres version is released, I just make a video about the new features and kind of go into details about what those features do, kind of technical. So these kind of episodes are very, very technical, right? So we go into details, like I try to explain some of the things I can, some of the things obviously above my head and I can't explain it. It takes time, but I'm very passionate with Postgres. I love this database. I did these kind of videos with Postgres 12. I started doing it with 12, maybe 11, I don't remember. And I did it with 13, and since 14 is in beta, and it's about to be released fully in a few weeks, I usually decided to, okay, let's go ahead and go through the new features of Postgres version 14. How about we jump into it, guys? Guys, welcome to the Backend Engineering Show with your host, Hussein Nasser. And how about we jump into the features that have been shipped with version 14 of Postgres. Yeah, what we're gonna review is actually the beta, but it looks like these are pretty much all the features, or at least the highlights, the most important features that is available in the software. Let's jump into the screen share now. All right, guys, Postgres SQL 14 feature highlights. So there are a lot of categories. There's performance, data types, new data type on SQL Server. There is administration kind of changes and tweaks and new features there. There is replication and recovery. So if you're using replication, you might want to pay attention to this. This is interesting stuff. And security, obviously, TLS authentication and things like that. So this is the categories. And I'll have some chapters for you guys to jump in and timestamp. Even if you're on a podcast, you can just click on the description, your favorite podcast player. You should see the description there with timestamp where you jump into the interesting part of the video where you're interested in this stuff. All right, performance. Postgres 14 continues to trend of recent releases in providing performance benefits to workloads of all sizes. This release has significant improvement in transaction throughput for Postgres. Beautiful, pretty, I love throughput, right? That have large number of connections to the database, regardless if they are an active or idle state. And this is basically a problem in all databases, to be honest, right? The more connections you have, the more CPU is being consumed just handling these connections and the Postgres database. Even if you're idle, you still do polling and stuff like that on the connection, and that kind of consumes stuff. So the Postgres team, apparently they figured out ways to work with large number of connections. Postgres 14 also contains additional gains in reducing B-trees indexing overhead, including reducing the bloat on tables with frequently updated indexes. So there's a link here that you can click and read more about it, but I'm going to summarize what's going on here. When you update a field in a row, and that field, if it has an index on it, Postgres needs to update the index to reference the new tuple that you just created. That's because of Postgres model of the versioning, right? It just always creates a new tuple. If you do an update, we keep the old tuple, right? And we create a new tuple with that new change that you made. Now this new tuple ID, the index is referencing the old tuple ID. So you need to go to the index and say, hey, index, by the way, there is a new version of this row. Here's the new tuple ID. Hey guys, Hussein from editing here. I forgot to mention something very important here. When you have an index on a column and you update that column, you have to update the index B-tree with the value that you just updated. How else would you search for the new value? That is the reason you update the index. When there is an index on top of the column you just updated, right? Obviously, you have to also update the tuple, but the main reason is because you have to update the B-tree itself.
the leaf to be on. All right, it's back to the video.
By the way, just a clarification. A row and a tuple is, in Postgres, they are kind of slightly different. When you say logical row, that means it's the latest representation of that row, logical row, right? The tuple is what tuple exactly you're referring to, because a logical row could have been updated 100 times, so it could have 100 tuples, right? So what is the final representation of that logical row is what is logical row refers to, while tuples, on the other hand, we really need to defer, like, okay, which tuple? Maybe you're reading an old logical row, old version of the row in an old tuple. That's what we mean by tuples here. So this makes sense. If you update a field that has an index, we need to go to the index and update the tuple ID, because that's what we store in the index. We only store the tuple ID. And if you have a covering index, you might have other columns that you store in the index as well. But Postgres also, when you update other fields as well that doesn't have an index, unfortunately, and this is fixed in Postgres, but still, really depends. When you update other fields that has nothing to do or no indexes at all, you still get a new tuple ID. However, for the long time, the index now still points to the old tuple. You don't want that. You still need to update the index, unfortunately, because if you now search for this, if you start searching the index and you found your entry and you go and you look at the tuple, you're pointing to an older version of the row, which is incorrect, right? So now you have to also go to the index and update it. That has been always true for Postgres 8.3 or something. They fixed that with something though called the heap only tuple, the hot optimization. And so that they did a trick in the heap. When you update something that has nothing to do with indexes, they do a little pointer, they do a little bit of trick there. So that old tuple, they keep it and they say, okay, by the way, this old tuple, actually, this is the new version of this old tuple in the heap itself, in the page itself. So that the index can stay pointing to the old tuple. But if you did a search and you found that old tuple in the index, you will go to the heap and you will find the old tuple. But the page will say, hey, index, how you doing? There is a new version of this index tuple, and here it is, right? This is called heap only tuple. Okay, obviously we can't always do that, because this only is true if the tuple that you just updated, that new version of the tuple, is in the same page, right? And you might say, Hussein, how can a tuple jump into another page? Well, a page has a size, dear. Of course, there is an 8K, right? And so this page gets full eventually. So if it's the last row, let's say, and you're updating it and it's full, it had to spill into another page, unfortunately, right? And if that's the case, you can't use this hot optimization. And in that case, you'll get this bloated index. So all of that, what I was talking about, is this optimization. Reduce the bloat on the table with frequently updated indexes. So they did a lot of tricks, all right, to reduce this tuple. They had like, this is called like bottom delete, I forgot what it was called, the bottom deleting indexes or something like that. So they essentially delete this bloat in certain situation and don't wait for vacuum to do it. So yeah, vacuum usually clear up these bloats, but you don't want to wait for vacuum to clean up all this stuff sometimes, right? So they did a better job at cleaning the bloat earlier, essentially. So yeah. All right, so we need to move a little bit faster, otherwise this video is not gonna finish, huh? Yeah, so for this, the indexes and all that stuff, the hot only tuple optimization, you need to optimize your fill factor so that you have your page filled to a certain extent. I'm gonna make a video talking just about that. It's fill factor and all that stuff, right? So yeah, you don't want to fill the page 100%, right? You need a little bit of a space so that you can take advantage of the hot optimization. All right, another optimization with the indexes, this GEST indexes, which stands for generalized search tree indexes. To be honest, I never use these kind of things, but these are the domain. I believe there's the same thing as the domain indexes in SQL Server, where you can essentially build your own expression kind of index, right? You don't want to build it on a specific integer field or string. You have like a fancy data type, right, that you created, like a spatial type, and you want to build a GEST index in this case to do your own algorithm to do the searching and indexing. So these are GEST indexes. So they did a bunch of optimization for that. They implemented covering indexes for that, so you can include a field in your index. I talked about covering indexes in my course, actually, Introduction to Database Engineering. This is a plug, by the way, guys. I have a course. It's called Introduction to Database Engineering. People seem to love it. Apparently, I got 4.7 on Udemy. Yikes. Thank you so much. So check it out. HusseinNasser.com/courses. All right. There are many improvements to query parallelism in Postgres 14. Okay, so query parallelism in general, the idea of using multiple processes to process a single query, right? And we see it all the time in the query planner. The Postgres planner will say, hey, by the way, I used a parallel index scan or a parallel heap scan, things like that. So it uses multiple worker to execute these kind of queries for you. In addition to overall improvements for parallel sequential scans, the return query directive in PG-SQL can now execute query with parallelism. All right, apparently it couldn't before, right? If you care about PL-SQL, this is something maybe you're gonna like. Refreshed materialized view can now use query parallelism as well. So a materialized view, if you don't know, guys, is a view that is essentially persisted, right? A view is a view. You create you build a query, a complex query of multiple tables, and then you just create a view out of it. That's just a view. So if you query the view, you always re-execute that expensive query every time. A materialized view is a view that is persistent asynchronously, essentially. So the query will asynchronously build, right? You can build it manually, and then when you query the view, it's persisted. You can hit the view directly, right? You don't get a cost of executing that. Obviously, there is a delay or whatnot, but so apparently, refresh materialized view, which essentially build that materialized view, is using parallelism. Niceties. Postgres 14 also introduced the ability to leverage query parallelism when querying remote databases using foreign data wrappers. This is apparently the ability to query other databases. And you can leverage the parallelism here as well. The release has also several improvements to the partitioning system. Partitioning, you know, guys, I talk about partitioning a lot, and Postgres improved the partitioning system a lot, right? Include performance gain when updating or deleting rows on tables where only a few partitions are affected. In Postgres 14, so let's talk about this a little bit. So if you're updating or deleting rows, right, you're going to provide a where clause where it has the key, the partition key, where it helps the database decide which partition to hit. A partition is just another table. Think about it, right? Huge table are partitioned by key, essentially. So now, if your query is hitting few partitions, there's an improvement in that particular case. Obviously, if you're hitting a lot of partitions, that's just a bad idea, right? That's just gonna slow you down as much as you're having a large table, right? That's why the beauty of partition, if you hit a single or maybe two partitions at most. If you found yourself doing partitioning and you're hitting the entire set of 100 partitions, maybe it's time to revise your query. Partitions can now be detached in a non-blocking manner using alter table detach partition concurrently. This is a very consistent thing you're going to see in Postgres. They add concurrently to any query. The moment you see concurrently supported, they add it to the index. But whenever you see concurrently, that means this is allowing you to rebuild the index or create an index without acquiring locks, because this is certain operations, DDL to be specific, require an exclusive lock. And when you do that, you can't write to the table. Other transactions are blocked, right? So if you add concurrently, Postgres will slow the process down, the process of creating the index or rebuilding on this or detaching the partition in this case, but it will allow transactions to write essentially. So if someone is trying to write, is gonna like pause the process that is creating the index or rebuilding the index, that is the blocking a process, and then allow the other process to continue, right? So it prefers DMLs over DDLs. Let's put it this way. Incremental sorting introduced in the previous window function. This is another features. This new release adds more capability and extended statistics, right? So statistics in general, this is another something new. I didn't read, I didn't know about it. Statistics in general, you know, the statistics like, okay, this field has this many value, right? This table has this many rows. This field has these kind of values. This is allows the table and the query planner to plan better your query and to choose, okay, maybe an index plan. Maybe an index is better than scanning the table, or maybe the index is just not worth it for this kind of query. Might as well just go to the heap and scan the whole table. It's better. These kind of statistics. Extended statistics actually allows you to build your own kind of expressions and related statistics, like, oh, this column's related to this column. So you can build complex statistics with this, and you can build even expressions with these things. Yikesy, not just fields, expression. Postgres has also supported compression on its oversized data column known as Toast. I talked about Toast a little bit in the previous videos. And Toast, if you don't know, guys, is when you have like a string field or a blob field, Postgres does not store that large string or large blob in the tuple itself, because there is a requirement in Postgres that a row should not span a page, and the page is 8K. So if you put the whole string in a large string in a tuple itself, the row will just spill over 2 pages, and that will complicate the database. So they decided, you know what, rows should never ever span 2 pages. That means I cannot put a whole large string in the tuple. So they decided to do this idea of a pointer. So that Toast pointer, they put the pointer in the column where the string is, or where the blob is, and they put it in a Toast table, so in a different table, and they chunk it up and they compress that thing. Okay, they now supported a different kind of compression, right? And it's called LZ4. I'm not familiar with it, right? But this is the new, it's another support. Apparently it's someone had been requesting the LZ4 compression, so it is now supported. You can turn it on by if you want to. I don't think this is the default. No, they didn't specify. All right, some data types and SQL. What have been new to this stuff? Okay, so what did they introduce? Then there's this, they building upon its existing support for range type. So they had a range type, which basically you create a range and you say, okay, this is the valid range in this column. Anything outside this range, please fail. Don't allow it to insert, right? That's what I understood. And it now adds a multi-range type. Nice, all right? So you can have a multi-range, right? So someone interested in that is non-contiguous. So the ranges has to be contiguous, apparently, to each other, right? Like a date, we're looking at the date from 2021 July 1st to 2021 July 31st. Now you can essentially break it up into, okay, from July 1st to July 31st, and from September 1st to September 30, and so on. All right. What else? They also added a general subscripting framework for retrieving information in nested objects. Oh, for those people who love JSONB, this is exciting. So you can write expressions like this, where you can, in the select statement. Oh my God, Postgres, what are you doing? JSON has nothing to do with this relational. Yeah, I don't know, man. I know people like JSON as a field, but come on. Have a schema already. Have a schema. Okay, this is controversial a little bit. People don't love. I know a lot of people say, well, I was saying sometimes I don't. My requirement, the client keeps changing the schema, so I like to just have a JSON field and just throw my junk there. Well, I never run into a requirement like that, so I can't talk to that. But I like explicit schema. Obviously, I'm not saying there are not use cases. Apparently there are. That's why it's popular, right? I don't like it. Here's the truth. I like my relation database to stay relational. Beautiful data type. Let me have a schema. This mumbo jumbo, I don't know, guys. So you can essentially take that. If you have a field of JSONB, which has your JSON document, you can essentially do substring and do, okay, the sub, get the key, and then get a sub, get the key. So you can basically run JavaScript. That's what we're looking at. If at the end of the day, you'll be able to run JavaScript in Postgres. That's what we're gonna end up with, right? But it's a very simple representation, right? So let's say you have a JSON document with a user, and the user has is an object with an ID and a name. So you can do select u, where the user field is the u, dot, not dot. You cannot do dot. Apparently, they are using this array. Not array, just this square bracket. So square bracket ID to get the ID, and then you can do a square bracket name to get the name, right? Postgres 14 also adds support for out parameters in stored procedures to allow group by clause to use distinct keyword to remove duplicate grouping sets. So that's another requirement with group by and store procedure, very specific, right? Another thing for the common table expression, CTE query, which is called also with queries. Postgres 14 add syntactic conveniences to search and cycle to help with ordering and cycle detection respectively. There is also new data bin function in Postgres 14 that can align timestamp with specific interval, a technique called also known as binning. All right. So there is a lot of stuff in type. So if you like this stuff, guys, Postgres 14 may be for you. Consider upgrading. Let's go to administration, one of my favorite parts. Postgres 14 makes numerous improvements to Vacuum, right? Vacuum, you know, this post process that's called Vacuum that cleans up Postgres with optimization geared toward indexes. AutoVacuum now analyzes partition tables and can propagate information about row counts to parent table. Very, very interesting. Looks like this is as part of the analyze. Is that it? Because the row count of the partition table is now propagated to the parent table. And we know this parent is the logical representation of the partition table, right? So now you do an analyze, and now you can essentially have more information about the row counts. Very critical for query planning. So now we know the planner, especially the database, knows that, okay, this table has this much rows, this partition has almost no rows, this partition has few rows. So it can decide what path it can take based on essentially the statistics. There are also performance gains in Analyze that can be controlled with maintenance IO concurrency. So I read about this maintenance IO concurrency. It's related to the effective IO concurrency, and then it boils down to how many processes or concurrent I/O operations you want to allow concurrently at the same time, right? This is a very low level change that you can make to your Postgres database. You can increase it, I think, up to 1,000, I believe, with 1,000 I/O, and that will allow you to execute this as much as 1,000 I/O, right? But the more I/O you have, obviously it can is gonna consume more CPU, because CPU needs to read these I/O, needs to manage these asynchronous I/O at the end of the day. So the more value, the more CPU is going to consume. And obviously it depends also on whether you have a hard drive, a spinning disk, or SSD. Usually what they recommend, if it's SSD, you can put in the hundreds, right? This is all really trial and seeing what fits your use case. To be honest, this is like advanced stuff. Even I don't know a lot about that. Postgres 14 includes numerous improvements of what information can be monitored, including the ability to track progress on copy using the pgstat progress copy. So if you run copy, you can track the progress of that. This release lets you track wall activity from the pgstat wall view and inspect replication slot statistics from the pgstat replication slot. So if you have replication, if you have replication, you're probably maintaining your wall, the write ahead log, and you're monitoring your wall. So this is very, very critical to see how large your wall is, and how is it affecting your bandwidth, the streaming, whether it depends really on whether you're using a streaming or logical replication. But monitoring wall is something you might want to do as a DBA. We're an administrator. If you're a backend developer, you might not worry about that stuff, but it's good. It's nice to know. It's nice to know this information. It doesn't hurt, right? If you're interested in database and how they work, just look at this stuff and you appreciate the work that the elite people are doing and building this stuff for us. And we just blindly do a Docker run Postgres, and we don't know how things work. Myself included. There are several new parameters I try to understand. There's just a lot of stuff. You can't possibly understand everything. I try. There are several new parameters in Postgres 14 to help manage connections. These include idle session timeout. So now if you have connections, and if you have like TCP connections to your Postgres database, and these are idle, your backend, let's say you have pooling, and the pool has not been visited for a long time. You execute something for a while, and then it stayed idle. You can now specify an idle session timeout. Okay, if nobody is actually doing anything, kill that session. Kill that TCP connection. So we have lower number of TCP connections, so we can essentially have a little bit more memory, and our CPU doesn't have to worry about this additional connections that are idle. Here's another interesting parameter. It's called client connection check interval, and that lets Postgres cancel long-running queries if the client disconnects. So I mean, let's say you're back and execute a query, and that query is taking a long time. It's taking sweet ass time, joining stuff, I don't know, doing all this stuff, and maybe it's doing full table scan. So it's a slow for some reason. And your client disconnects, and it's expecting to return a result, right? After the long query is executed, you need to return the result. However, this particular scenario is absolutely useless, because Postgres will have taken all that time to fetch the rows, consume all the CPU memory, only to discover that the connection has been closed, while it was after the fact, because it doesn't know, right? Once the query has been executed, the socket stays, right, in the Postgres side of things, right?
And the Postgres goes on and execute the query on another process, right? And then once it tries to compose the result, everything is ready, it tries to push it to the socket, it pulls the socket and discovers the socket is actually closed. And at that time, it's actually just, it's too late. This particular parameter, which is client connection check interval, allows Postgres to periodically check the socket, even if the connection is running, right? So yeah, there's an additional overhead to check to pull the socket. And there's a little bit more details, whether you're using Unix or Windows. It depends whether it is supported or not. I don't know the details, but it needs to pull the socket every now and then, right? So if you just start it and if the client immediately disconnects, Postgres can pull this socket and say, okay, after every 100 milliseconds, let's pull. And if the connection is closed, let's just kill the query. Let's not go ahead and execute the whole query, right? So if you disable this, I think a value of 0 means the old behavior, which is go ahead and execute the whole query until we interact with the socket, and at that time we basically we kill the socket. The reindex command can now process all of the child indexes of a partition table, and Postgres 14 adds pgamcheck utility to help check for data corruption. Okay, that's nice. Here's the thing, I didn't know that. I thought reindex, when you reindex the partition, the table itself, that is the parent table, I kind of assumed that all the partitions are gonna be reindexed. Apparently this is not true. So if you just thought that, maybe you have to have Postgres 14, or if you're using Postgres 14 and you're running reindex on your parent table, thinking that all the partitions will automatically get reindexed. Apparently that is not true. Who knew? Okay, that's a new thing to me. So Postgres 14 fixes that. To me, it's a bug, right? Not really a feature, Postgres. It's a bug. If I reindex the parent, I expect everything to get reindexed in the children, right? It's just by design. Again, people might disagree with that. Replication and recovery. Okay, what did we add? Replication and recovery. Postgres 14 adds numerous performance benefits for logical replication. So this kind of not streaming, where we stream the binary content of the wall, we stream the logical wall representation here. Okay, so it's lighter weight, I believe, and it's compatible with all the releases too. So you can like logically replicate Postgres 14 or 10 to Postgres 14, because we're dealing with logical representation that usually they maintain compatibility at that level, at the logical level. While the binary state, that always changes. You cannot guarantee, right? Postgres version always changes the binary representation. That's why if you're using Docker and you backed up a volume of Postgres 13 and you try to sneak in that volume and you spun up Postgres 14 and you shove it that volume of a Postgres 13 data, it's gonna yell at you. It's like, what the heck are you doing? That's a completely different files. So it's gonna freak out, right? I tried that with 12 and 10, I believe, and I got yelled at. So I expect to get yelled at with 13 and 14 too. Including the ability to stream in progress transaction to subscriber instead of waiting for them to be completed. Very, very powerful stuff, right? As the transactions are in progress, you're streaming, and there you can see this. You can see this as both pros and cons, right? Because you might, if you roll back the transaction, all of a sudden you just streamed junk to the standby, and you wasted bandwidth just so that it rolled back. But let's be optimistic a little bit, and be a little bit optimistic and think that things will succeed for a minute. That is good stuff, because if you stream on Progress, then synchronous commits, right? Synchronous replication are extremely fast because boom, just like that. I'm not gonna wait for the whole wall to get filled and just shove that wall down the network throat, right? It's much faster. The alter subscription makes it easier to add and remove republication using the add drop application syntax. Okay, that's better syntax. I love it. I love it. I love it. There are performance improvement in Postgres 14 to how Postgres starts up when in a crash recovery. I'm falling asleep, guys. It's a little bit late for me. I'm a dad now, right? So I sleep at 9 and there's a dog barking. Oh my God, Pugsley! Let me finish this video. And you can now use PG Rewind on a Postgres instance that is in the standby mode. That's good. Okay, all right, final thing. We're almost done, guys. If you're still watching, I really need to give you a kiss because you are a badass. Give me a like. That's okay. I was still watching until security. You reached the end. This is a long video. You powered through, my friends. Security. Postgres 14 adds the ability to give user universal read-only and write-only privileges. Boy, I needed this. You have no idea how much I wanted to kind of read a master read-only role. It's like, I don't care. This user is read-only. Is gonna read is only supposed to read. I want to create a REST URL route that this route is only gonna read stuff. So I'm gonna create a user with read privileges, right? So now I have to create a user and I have to create a role and read-only role for every single table that is there. Oh, very hard, right? It just complicates things. This way, hey, this guy's a read-only. It's gonna universal read-only or universal write-only. Why would you have a write-only? That doesn't make any sense. You need to read to write. That doesn't make any sense. I don't know. Who requested write-only? I can't think of a single use case where you only write. Right? Logs? I don't know. Well, for security reason, hey, you are allowed to append to this thing, but you can't read it. Well, maybe this is actually not a bad thing, right? Hey, you are a logger. You just log stuff. You're not allowed to read what you log, or you're not allowed to read anything. But most of a query is actually like a select or an insert into select. That won't work in that case. But yeah, you get my idea. So PG read all data, PG write all data. That's really good stuff. This release also defaults to using Scram SHA 256 for password management on new Postgres instance. So this is the new default now. Postgres Scram SHA 256. Additionally, the client cert parameter in PGHBA-conf must now use either of the values verify CA or verify false. So better verification, better client auth, better password management. All right, guys. So it is Postgres 14 seems like a very exciting performant release, especially when you use like replication, right? Indexes, admin stuff, vacuum, all of that stuff. It looks like a very performant release. There's a little bit of features when you have the data type like JSON, manipulation, stuff like that. But overall, I kind of like it. I'm going to start using these features, I believe. All right, guys. I'm going to see you in the next one. You guys stay awesome. Goodbye.